Good morning, class. I just wanted to quickly go over the small scale model with everyone so we were all on the same page this morning. I've already actually covered this with Monday, Tuesday group. So without any further ado, let's go ahead and get started. Those of you that are in the Monday, Tuesday group, don't worry about watching this. The first thing that the blurb of information gives us in the Discovery Lab is that the sun is about 109 times larger in diameter than the Earth, and the Earth is about 3.7 times larger in diameter than the moon. The moon's 30 times farther from the Earth than the Earth's diameter, and the sun is 400 times farther away from Earth than the moon. So you actually have to read that information to find out the size of the Earth and the moon and the sun in comparison. So what I asked you to do using the notes that I gave you on planetary motions, which is what you were supposed to do first, was take those notes. Everything was there. You just had to turn it into 2-column notes. At any rate, in that information, if you went through the slides, you would see that there was also a data table. So I'm going to set up the data table as it was. The moon, the Earth, and the sun are the 3 planetary bodies that we're looking at in this case. That's what we'll mainly be studying in this class when we talk about planetary motions. So I wanted to be able to let you see the difference in size and the vastness of the sun. So you were supposed to form a hypothesis. If we look at the small scale model of the Earth, sun, and moon, which one would be the largest? Which one would be the smallest? These are things that you need to write in your hypothesis. Again, so we have the Earth, the moon, and the sun in our model, and we want to know the size, and we're using a scale that's centimeters, and we want to know the distance. And again, we're using a scale that's centimeters. So we are told that the moon is 1 centimeter in diameter. 1 centimeter in diameter, and then we are also told that the Earth is 3.7 times the size of the moon. So 3.7 times the size of the moon would be 3.7. Then they tell us that the sun is 109 times larger than the diameter of the Earth, the sun's diameter. So if the Earth is 3.7 and the sun is 109 times that, you can figure in your head the math, or you can get a calculator out and do it. I like to do things longhand. So that tells us that the sun is 403.3 centimeters in our scale model. 403.3 centimeters in our scale model. And then it tells us further about the distances between the bodies. The moon is 30 times farther from Earth than the Earth's diameter. So 30 times farther than 3.7 is 111 centimeters. And then when we look at the size of the Earth, the distance of the Earth between the Earth, there's no distance there. So then it tells us that the moon is 30 times farther from the Earth than the Earth's diameter, and the sun is 40 times farther away from the Earth than the moon. So if it's 40 times further away than the moon is, then we can multiply 111 times 40. Oh, it's not 40. I think it's 400. 400, yes, excuse me. I knew that looked wrong. Okay. So 44,400 centimeters. 44,400 centimeters, I'm pretty sure, is approximately 4 football fields, just to put things into perspective. If you take a look here, you can see I have created my Earth. I made it green, Earth, and my moon, blue, my blue little dot over here. And if we were to try to measure out the diameter of the sun, it literally would stretch halfway across my room. I have no one here to help hold this, and you wouldn't be able to see it anyway because it goes halfway across my room. So with that said, the diameter of the sun is extremely massive in comparison to the diameter of the Earth and the diameter of the moon. The distance between the moon and the Earth is much smaller than the distance between the sun, and the earth. That distance is approximately 4 football fields. So with that in perspective, there are 3 questions you're supposed to answer. Please make sure you put the entire lab report in your notebooks. It's all pretty much written there for you. All you have to do is fill in your hypothesis. At this point, you could put your hypothesis as being accurate, but you need to back it up with data. So when at the end of the lab report, in your conclusion, where it asks you specifically, why or why not is your hypothesis correct, please make sure that you explain using the small scale model data. If you have any questions, my Thursday, Friday group will be here tomorrow. I'll answer those questions then. The lab will be due on Friday along with the current event article choice. I think that's it for this. I'll be getting back to you with those planetary motion notes shortly. Bye.